Hello viewers, welcome to my channel. I'm Hashim Ali Khan. So now in this video I'm going to explain you about the theory of the topic regression analysis. So before going to examination, if you brush up your knowledge on the subject on each topic, you can be able to attempt the theory question very confidently. So I have already uploaded the theory on the last subject, income tax. I got a very good response. Number of comments I am getting every day on the videos of income tax theory I have given. So students have requested me to give the same type of videos on the theoretical part of business statistics because the coming examination is business statistics. So I have decided to give short videos on only theoretical part of these topics of business statistics. So the topics which I have decided: regression analysis, index numbers, time series, set theory, permutation and combination, probability, then theoretical distribution, binomial, Poisson, normal. These are the short videos I am giving, so that before going to write the examination, if you watch it with full concentration, you will be full confident in writing the theory, because theory is also very important. Don't depend only on problems. In examination question paper, almost to 40% compulsory theory you have to write. So if you watch, definitely you can get a good comment. Apart from that, I have uploaded all the problems of these topics. So go to the playlist of my channel, select the subject business statistics 2, select the videos of regression, index numbers, time series and all probability. All these videos you can find there. Go watch the problems videos, get a full command on the subject. It's a scoring subject. You can enjoy learning. Not only from just passing the examination point of view, you will get the confidence on the subjects. So now I'm going to start the theory of regression analysis. This is the first topic of business statistics. See here, business statistics is a statistical technique which shows the functional relationship between two or more variables. Functional relationship between two or more variables. There are a number of cases where variables will have some relationship. So in order to find out what is the functional relationship between the two variables, we apply the regression technique called the statistical technique called regression analysis. Simple words, I'll say. A regression analysis is a statistical technique which is applied to find the functional relationship between two or more variables, so that it will be helpful for prediction and forecasting. That's all. This is the definition or complete meaning of the term regression analysis. Now I'll give you some examples so that the concept will be more clear. In a number of cases, we have some relationship. Simple example: sales and advertisement. Sales and advertisement are two variables and both have some relationship. What is the relationship? Everybody knows when business spends more money on advertisement, the sales will increase. Higher the advertisement, higher will be the sales. Lower the advertisement, lower will be the sales. That is the relationship. Now this relationship, we can put it in a functional form so that we can be able to estimate one variable given the other variable. That means there should be some cause and effect relationship between the two variables. What is the cause and what is the effect? The cause is we are increasing the advertisement expenditure. And what is the effect? The effect is sales are increasing. So in simple words, we can say advertisement is independent, whereas sales are dependent. Because advertisement is in our hand, we can spend more, we can spend less, but sales depends on advertisement. So sales are dependent variable, advertisement is independent. Now we make a functional relationship between sales and advertisement so that we can be able to predict the sales for any given amount of advertisement. Suppose if we have formed a relationship, an equation we have formed. By using that equation, we can be able to estimate if we spend 5 lakh rupees on advertisement, how much would be increase in sales. If we spend 10 lakh rupees on advertisement, how much would be the increase in sales. We are estimating the sales. we are estimating the sales. So this is the regression analysis. Simple words, regression analysis is a technique which is applied when two variables are there in which we have cause and effect relationship. We can estimate the dependent variable when the value of independent variable is given. That is regression analysis. Now, simple and multiple regression. We have two types of regression, simple and multiple. Simple regression means we are studying the relationship only between two variables. When only two variables are there and we are finding out the functional relationship, it is called simple regression. Just like advertisement and sales. We assume that sales are dependent on advertisement. Only two variables, advertisement, sale. This is simple regression. Simple regression. Multiple regression, more than two variables are there. When we study more than two variables, what is the functional relationship of all the variables? More than 2, 3, 4, 5, 6. It is called multiple. Simple example, sales. Sales does not depend only on advertisement. Sales will depend on the price of the product. Sales will depend on the income of the product. Sales will depend on the competition in the market. So many factors are there which affects the sale. Among those factors, one important factor is advertisement. So we should never think that sales are completely dependent on advertisement. No, it is dependent on innumerable factors. So when we consider all the variables, it is called multiple regression. That's it. Now, importance or significance of regression analysis. From business point of view, so regression analysis is very important because this regression analysis can be used for prediction purpose, for forecasting purpose. And the first function of the management is planning. Planning requires forecasting, and this is the technique of forecasting. Simple words. Regression is a technique of forecasting, and forecasting is used for planning, and planning is the main function of the management. So in simple words, we can say it's very significant. It's very important for the functions of management. The management can perform its functions by using this regression analysis. It's a handy tool in the hands of the management. Secondly, this regression analysis will be very much used for planning, for policy making of the management. Management has to make a number of plans with the help of so many resources. So by using this regression analysis, the management will be in a position to make the policies, to make the plans for his business. That shows the importance of this regression analysis to businessmen. Next comes limitations of regression analysis. See here, regression analysis is very important, but it also suffers from some limitations. There are some drawbacks of the regression analysis. What are the limitations? The first drawback is regression analysis shows linear relationship between the variables. Linear relationship means proportionate relationship. That means if 10% is the increase in advertisement, 10% is the increase in sales. If 15% increase in advertisement, 15% increase in sales. This is proportionate. It is called linear. The regression analysis assumes that there is a linear relationship between the variables, but in practice, it is not compulsory. It is not compulsory. Many variables will show non-linear relationship. Advertisement in expenditure increased by 10%, sales are increasing by 25%. It may happen. It may happen. We have increased advertisement by 10%, whereas sales are increasing by 25%. There is non-linear relationship. This is the limitation of regression analysis. Regression analysis assumes there is linear, but in reality it is non-linear. Non-linear. That is the first limitation. Second limitation is, once a linear relationship is made between sales and advertisement, we assume that this linear relationship will be continued for a long period of time. But it is not necessary. The relationship between the variables may change from time to time. We have made the relationship now. In the next year, the relationship may not be true because the conditions might have changed. So we cannot assume that this linear relationship will remain same always. That is also one of the limitations. So another limitation is due to the dynamic conditions, we cannot rely on regression analysis because the changes in the environment, in the variables may occur. So these are some of the limitations of regression. Differences between correlation and regression. See here, these two are related techniques. Correlation and regression are related techniques. What is the similarity? And then we'll discuss about differences. Similarity is both will show the relationship. Correlation is a statistical technique which shows the relationship between variables, and regression also expresses the relationship, functional relationship. So both are related, correlation as well as regression, but there are many differences between correlation and regression. First difference, correlation is a statistical technique which shows the nature and degree of relationship between two variables. Nature of relationship and degree of relation. Nature means the two variables are positively related or negatively related or unrelated. So simply it shows the nature. What is the nature? Both are moving in the same direction. Simple example, in case of sales and advertisement, there is a positive relationship. There's a positive relationship between sales and advertisement, because when advertisement increases, sales also increases. So we can say there is positive relationship between sales and advertisement. What about price and demand? If you see the relationship between price and demand, there is inverse relationship. When price increases, demand decreases. When price decreases, demand increases. So there is inverse relationship between price and demand. So some variables we have positive relationship, some variables we have negative relationship. This is the nature of relation. Apart from the degree of relationship, high degree of relationship or low degree of relationship will be explained by correlation. We cannot predict the values. There is no cause and effect relationship in case of correlation, but in case of regression, there is cause and effect relationship. We must know which is the independent, which is the dependent variable, because independent variable will be given and dependent variable we can be able to find out by making the relationship. So prediction is not possible in case of correlation. In regression analysis, we can make the prediction, we can make the estimations. Like this, some differences are there between correlation and regression. So applicability, practical terms for a business management, correlation is not so important because it cannot be used for prediction. Whereas regression analysis is very highly required for business organization because they want to predict. So prediction is possible with regression. Prediction is not possible with correlation. The correlation coefficient is independent of change in scale and change in origin. Change in origin and change in scale. But regression coefficient is independent of change in origin but not change in scale. So these are some of the differences between correlation and regression. Now there are two types of regression because we have two variables. There are two variables x and y. One variable is independent, the other variable is dependent. Simple example, if x is the independent variable, y is the dependent variable. If any change occurs in x, corresponding change will occur in y. Two variables are there. That's why we will have two regression equations. One regression equation is x on y, the other regression equation is y on x. So regression equation x on y will be used to predict x. To predict x when y is given. The regression equation of x on y is used to predict x when y value is given. Similarly, regression equation of y on x is used to predict y when x is given. So if you want to find out y, y on x. If you want to find out x, x on y. So remember this point. Remember this point. These are the two regression equations. Now properties of regression equation. In examination, in short question, you may get a theory. Explain the properties of regression coefficients. there are two regression coefficient. One regression coefficient on x on y and the other regression coefficient of y on x. So two regression coefficient. What are the properties of the two regression coefficient? Listen carefully, watch carefully, so that in examination you can write with confidence. The product of the two regression coefficient gives the square of correlation. The standard symbol for correlation is R. Small r is the symbol for correlation. So when you multiply both the regression coefficient, the regression coefficient symbol is bxy. Bxy is the regression coefficient of x on y, and byx is the regression coefficient of y on x. X on y, bxy. Y on x, byx. These two are the regression coefficient. If you multiply the regression coefficient, you will get the square of correlation. Square of correlation, first property. Second property, the root of the product of the two regression coefficient gives the correlation coefficient. So if you want to find out correlation coefficient, put the product of the two regression coefficient under root. That means bxy into bxy under root. What you will get? R, correlation coefficient. So two properties over. Third property, both the regression coefficient are the same sign. See here, if you get bxy positive, then byx must also be positive. If you get bxy negative, then byx should also be negative. That means both the regression coefficient must have the same sign. Both must be positive or both must be negative. You should never get one positive, one negative. Never. Both may be positive or both may be negative. Next one, the arithmetic mean of the two regression coefficient is greater than the correlation coefficient. If you take the average of the two regression coefficients, the regression coefficients are bxy and byx. Take the average bxy plus byx divided by 2. This is the average. This average should be greater than correlation coefficient R. Then last regression. If one regression coefficient is greater than unity, the other regression coefficient should be less than 1. Very important property. If one of the regression coefficient is greater than unity, unity means 1. Unity means 1. If bxy you got 1.5, suppose more than 1, then byx you should get less than 1. That means if you get bxy 1.5, then byx is equal to 0.8. That is correct. That means one regression coefficient, if it is more than unity, the other regression coefficient must be less than unity. That is a must rule. Both should not be more than 1. If you are getting bxy 1.5 and byx 2.5, that means your calculation is gone wrong. Both will not be more than 1. If one is more than 1, the other should be less than 1. Both may be less than 1. It may happen. There's a possibility that both the regression coefficient may be less than 1, but both the regression coefficient never be more than 1. If one is greater than 1, the other must be less than 1. That is the property. So these are the 5 properties of regression coefficient. Now I'll explain you about the formulae. All these formulas I have applied in the problems. So watch the problems which I have given in the playlist and in the subject Business Statistics 2, Regression Analysis. So briefly I am explaining the formulas. Formula for regression equation of x on y. So two regression equations, x on y and y on x. So pehle x on y, regression equation x on y. The formula is x minus x bar. X bar means mean of x. X minus x bar is equal to bxy into y minus y bar. Bxy is called regression coefficient. Bxy is called regression coefficient of x on y. Y minus y bar is the mean of y. So before calculating this, you must know what is x bar and what is y bar. Mean of x and mean of y. Then you have to calculate bxy. So regression equation of y on x. So y minus y bar is equal to byx into x minus x bar. The difference is here you are having bxy, here you are having byx. This is the regression coefficient of x on y and this is the regression coefficient of y on x. Right? Now regression coefficients. Now regression coefficients of x on y. So So this is the regression coefficient of x1y, bxy. So what is bxy formula? Summation xy divided by summation y square. But this formula will be used when the deviations are taken from actual mean. When deviations are taken from actual mean, this is the formula. So again I repeat, if you want the perfection, go to the problems which I have already given. In those problems I have applied this formula. So bxy summation xy by summation y square when deviations are taken from actual mean. Now byx, one more formula is there, r into sigma x by sigma y, standard deviation of x by standard deviation of y. In some problems, the value of r is given, correlation coefficient is given, and standard deviation of x and standard deviation of y is given. In that case, the formula will be r into sigma x by sigma y. You will get bxy. The value of bxy will remain same. It depends on the information given in the problem. So according to the information given in the problem, we apply the formula. Similarly, bxy is equal to summation dx dy minus summation dx into dy by n divided by summation dy square minus summation dy whole square by n. The above formula is used when deviations are taken from assumed mean. If the actual mean is in fraction, so you can take the deviations from assumed mean. If you take the deviations from assumed mean, then bxy formula, this formula you have to take. If the deviations are taken from actual mean, then you have to apply this formula. A very short formula if deviations are taken from actual mean. A long formula when deviations are taken from assumed mean. All these things I have explained in those problems. So now regression coefficient of y on x. This is x on y. Now y on x. If you remember x on y, easily you can transform into y on x. No need to put extra effort. Same procedure. So byx. Byx is the regression coefficient of y on x. Bxy is the regression coefficient of x on y. Here x on y, here y on x. So byx is equal to summation xy by summation x square. Numerator remains same. Here numerator summation xy, here also numerator summation xy. Here denominator is summation y square. So when you are having xy, so here denominator y square. Here you are having yx, so denominator you have x square. This is the difference you have to remember. Summation byx is equal to summation xy by summation x square when deviations are taken from actual. Byx is equal to r into sigma y by sigma x. See here also bxy is equal to r into sigma x by sigma y. Numerator is sigma x. Here numerator is sigma y. Because what is the first symbol here? Y. The first symbol is y. So here numerator you have to take y. Here first symbol is x. So numerator you take x. Sigma x. So sigma x by sigma y. Here sigma y by sigma x. Now same. Byx is equal to summation dx dy minus summation dx into summation dy by n whole by summation dx square minus summation dx whole square by n. This formula will be applied when deviations are taken from assumed mean. Same is this one. The numerator will remain same. Summation dx dy. Numerator remains same. Denominator here summation dy square. Here summation dx square. Minus summation dx whole square by n. That's all. These are the three formulas for regression coefficient of x on y and y on x. Now note, the correlation coefficient will have the same sign as that of regression coefficient. That means if the regression coefficient bxy and byx are showing positive sign, the correlation coefficient will also be positive. If the regression coefficients are showing negative sign, then correlation coefficient will also be negative. That's all. So this is the complete theory regarding regression analysis. So after watching this video once, twice, definitely without any difficulty you can be able to write in examination the theoretical part of regression analysis. Next video, inshallah, I will take up the next topic called index numbers. So keep watching, enhance your knowledge, get the confidence on the subject. So if you are satisfied with my lecture, give a like to the video, share my channel in your friend circle group so that more students can watch the video and enhance the knowledge. And subscribe my channel if you have not yet subscribed. Give your comments. Inshallah, we'll continue the next topic in the next video.